Hi everybody. So we have been spending some time talking about solutions in class, and we decided that solutions are homogeneous mixtures in which you have a solute dissolved into a solvent. Your solute is the thing being dissolved, solvent is the thing doing the dissolving. So when we were talking about solutions, we were talking about all we talked about was how we could calculate the concentration of a solution. So how much solute in moles do you have dissolved in liters of your total solution overall? So let's start again by modeling out what some solutions would look like. We're going to consider a concentrated solution versus a dilute solution. So what does that actually mean to us? Well, concentrated means you have a lot of stuff packed into a small amount of space. So let's say that our beaker's filled about halfway with solution. I'm going to do the same volume in both of these scenarios. But what would look different about them? Well, my concentrated one should have more particles in the same amount of space. Whereas if I had a dilute solution, I would have less particles in that space. So in the dilute solution, I have a lower number of moles per unit volume. So if they have the same volume, I have less moles in my diluted solution, whereas with my concentrated, I have more. So here, my pink particles represent my solute. This is the stuff dissolved in my solution. And then all that area around it would be my solvent particles, the thing that dissolved the solute into solution. I'm just drawing the solute particles to make the system look kind of clear. If I tried to draw a bunch of particles in here, it would look a little bit more confusing. So I'm just going to say that this represents my solvent. So yesterday we learned about how to calculate the concentration of a solution. So let's say we're in the lab, we want to make a solution of sodium hydroxide. How would we do it? Well, sodium hydroxide typically gets delivered in the form of solid pellets, which means you would be able to know the mass of your sodium hydroxide. But if you want to make a solution out of it, you have to calculate concentration of that solution. How would you do it? Well, you need to know the amount in moles of your sodium hydroxide that you are dissolving in some amount of your solvent. Most typically, your solvent's going to be water. It's called the universal solvent. It's the thing that you make most solutions out of. So if I wanted to make a sodium hydroxide solution, I would have to know how many moles of sodium hydroxide I have per liters of water that it's dissolved into. What's that going to end up looking like? Well, it's going to just look like the molarity equation. So molarity, concentration, is equal to the moles of our solute divided by liters of solution. So for this example, this would be moles of our sodium hydroxide per liters of solution. And here our solution would only be coming from the solvent, which would be water. So let's say that I want to now make a solution that is diluted from my original one. I want my concentration to be lowered. How can I do that? Pause the video here, think for a second what that would look like in the beaker and how I could possibly accomplish that. Then come back to check your prediction. Okay. So again, we're thinking about how we want to dilute a solution. So let's look at the equation for molarity one more time. So molarity is equal to moles per liter. So what's one way that I could potentially have a diluted solution? Well, I could just add in less moles to my system, and then I would have less moles per same amount of volume. So if I had the same volume that I had before, and I add less moles of my solvent to it, decrease moles, then I would have a less concentrated solution. It would be more dilute than previous. So I could decrease moles of solute. That's one way I could do it, but that would kind of require me to start over from scratch, right? I'd have to add in less moles of my solute than I did previously. What if I don't want to start from scratch? What if I already have a concentrated solution and I just want to take that solution and dilute it? Well, the other way that I could do that is I could just add more solvent. So if I have a solution that has, let's stick with our 4 particles again in it. If I have 4 particles in my solution, or 4 moles in my solution, and I increase the volume of my solution by adding more solvent in, now these particles have even more space to roam around. So this would allow me to keep an original solution that I've already made and just add water to it and cause it to be more diluted than before. So in this case, I'm increasing my volume in liters. So if I try to dilute my solution, how would I be able to calculate the concentration of this new solution? Well, good news is we have a formula for it. Yay! And that formula is called the dilution formula. So if I wanted to calculate the concentration of a diluted solution, I would use this equation right here. I would take into account the original concentration of my solution and how much volume of that solution I had, my volume of my original solution. So this is our original concentration and volume. So in that solution, I know that I have some number of moles dissolved in some volume of solution. If I'm just diluting it, the only thing I'm changing about that system is the volume. I'm not changing the amount of stuff that I have dissolved. My number of moles isn't changing. So what I would consider then is the concentration of my new solution times the volume of my new solution. So this is new or diluted concentration and volume. So why does this work? Well, think about the units here. Units for molarity are moles per liter. So I would have moles per liter times liters of my original stuff equal to moles per liter times liters of my new stuff. And if I cancel this out, liters, I have moles equals moles. So my amount of stuff, again, is not changing. The amount of stuff I have dissolved is not changing. I'm just changing the volume of my system by adding more solvent in, which is then causing my concentration to change because my particles have more space to roam around in the solution. So let's do an example problem here to help us out with this dilutions formula. What volume of 12 molar sulfuric acid, H2SO4, will be needed to make 1.5 liters of 1.5 molar solution of sulfuric acid? So let's think about what this looks like. I'm basically being told I have a 12 molar solution of sulfuric acid. So I have in sub-beaker 12 molar H2SO4. And if I'm in the lab, I don't want to work with 12 molar sulfuric acid. It's really highly concentrated, pretty dangerous stuff, smells nasty. I want to work with something at a much lower concentration for my purposes. And what concentration do I want that to be? Well, I want to end up having a solution that is only 1.5 molar H2SO4. So let's say I'm running some experiment and I know I want to work with a lower concentration of my acid, and I know that I'm only going to use 1.5 liter only. I'm going to use 1.5 liters. 1.5 liters is actually quite a large amount if you think about it. So I'm going to use 1.5 liters of my 1.5 molar sulfuric acid. So what I want to do is I want to dilute my 12 molar acid to get me there. So I want to find the volume that I need to add to dilute this. When you do a dilution, I'm sure some of you have seen this in the lab from when I had their initial phenomenon stuff out, but when you do a dilution, what you can do is add some known quantity, some known volume of some known concentrated acid into what's called a volumetric flask. So I would add it into there. Then what I can do is dilute it up to a certain mark with water. And then that acid that's of a certain concentration now has all that space to roam around, gets mixed in, and that helps dilute my acid. So I know that this is the new and concentrated volume that I want to make. I want a new concentration of 1.5 molar. And how much do I want to use? 1.5 liters of it. I know that I am starting out with a concentration of an acid at 12 molar, and I want to find the volume that I need to dilute. So if I set up my formula, I have M1V1 equals M2V2. I know information about my new diluted concentrated acid. What I want to find out is V1, the volume I need to add to my original acid. So again, it really doesn't matter if you set this up as M1V1 is your original or M1V1 is your new and diluted. As long as you have the new and diluted on the same side of the equals and the original concentration and volume on the same side of the equals, you're fine. But I'm just going to stick with what I have in the notes packet so that way I'm consistent. So my M2 and my V2 I'm going to say are my new and diluted concentration and volume, which is 1.5 liters and 1.5 molar. I want to solve for V1. I don't know my volume. So how do I do that? Well, all I have to do is isolate my variable. I want V1 by itself, so I would divide both sides by M1 and end up with the formula V1 is equal to M2 V2 divided by M1. And now I just plug things in. The volume of my original acid that I need to add in is equal to the molarity of my new acid, 1.5 molar, times the volume of my new acid, 1.5 liters, divided by the concentration of my original acid, 12 molar. Take a look at the units. Molar cancels with molar. I'm just left over with liters, which is exactly what I want in this problem. So the volume that I need to add in is 0.19 liters. So this is how much concentrated sulfuric acid I would have to put into my volumetric flask. And then I would dilute to the 1.5 liter mark to make my new solution of a 1.5 molar concentration. So let's do one more together. Let's take a look at the next problem. What volume of water must be added to make 2.5 liters of a 2 molar solution of hydrochloric acid from 16 molar solution of hydrochloric? So again, think about what this one is asking you for. I have a 16 molar solution of HCl. That's my concentrated acid. I want to make a 2 molar solution of HCl, and I know I need 2.5 liters of it. So let's start out with our formula. M1V1 equals M2V2. So in this case, again, I'm asking to solve for a volume. I know my original concentration, I know my new concentration, and my new volume. So again, I'm going to solve for V1, which we know is equal to M2V2 divided by M1. So let's fill in our information. V1 is equal to 2 molar times 2.5 liters divided by my original concentration, 16 molar. Units cancel. And when I plug this into my calculator, I end up with a volume of 0.3125 liters. So what is this actually representing? So remember, this is the volume of the 16 molar hydrochloric acid that I would need in order to dilute this. So this volume represents volume of 16 molar HCl needed to be diluted. But that's not what this problem is asking me for. This problem is asking how much water do I need to add to dilute this? So think about what this would look like again. So here's my volumetric flask, garbage. Let's make this look at least a little bit better. Okay, garbage, but better garbage, pretty garbage. All right, so what I'm doing here is I'm adding in 0.3125 liters of my concentrated acid. But I know that I need a 2.5 liter solution. So that means the rest of this has got to come from added water. So how can I find how much water I need to add? I take my total volume, I subtract out the amount of concentrated acid that I needed to add in, and that's going to leave me with the amount of water that I needed to add in order to make this system work. If I cut this off, I'm going to round it to 2.2 liters of water that I need to add. I know, don't yell at me through the TV screen or through your iPad screen. I know that technically I would need to round it to one significant figure because of that one right there, but I'm going to round it to 2 just because I want to give us another decimal on there. Otherwise, it wouldn't be that exact. All right, so try this last one on your own. Check in with the answer key, and when you're done, come on back.